Hi, I'm Eric, and I'm presenting on how the sky is the color it is. Now, let's start off with something simple that we've all learned in high school. When we have two different mediums, aka two different materials, and light is going through them, it will simply change angle when it goes from one material to another. It changes from theta 2 to theta 1. Now, something similar happens in the sky, and we call it scattering. Now, what scattering is essentially, as you see in this diagram, light will come in, and there's a ball that is a different medium. Therefore, light will actually interact with this ball and get scattered. Now, clearly, this naive view cannot fully explain what would happen when light encounters a ball, right? Because it's not fully normal. It's more complicated than that. This is just a straight plane, but on the ball, there's some curvature here. So it gets quite complicated. And what mathematicians have done is they use Maxwell's equation to actually solve this. And how they use Maxwell's equation is that Maxwell's equation sees light as an electromagnetic wave. Okay. In here, we just see it almost geometrically, almost as if it's a line. Maxwell's equation digs one step deeper and sees light as electromagnetic waves. And it can set up these complex partial derivatives, which will then be used to calculate how the wave is actually scattered. Now, if we look at this, we can see when light encounters a ball, it actually scatters in some very interesting and almost beautiful shapes. And this is what we call Rayleigh scattering and MIE scattering. Now, what's the difference between Rayleigh scattering and MIE scattering? Well, first is the size of the ball, right? When the ball is bigger, it will scatter differently compared to when the ball is smaller. Sorry, I should draw this as a wave. Now, this affects how it's scattered and how this effect is seen in the sky. Now, what does this have to do with the sky? The sky has all these small dust particles, right? There are dust, there's air, right? Air is a particle. There's all these different chemicals in the sky, and light sees them as small round balls. Now, the dust will obviously be bigger, and the dust will most likely be causing MIE scattering because it's so much bigger. And air will be causing Rayleigh scattering because it's so much smaller. And one particularly interesting fact about how the equations resolve themselves is that MIE scattering is wavelength independent, which means regardless of what wavelength the light comes in, it will always scatter in a similar shape that's a bit like this. It scatters like this. So there's actually still quite a bit coming at you if light comes in this way and you're looking at it here. Now, for Rayleigh scattering, when light comes in, it scatters in all directions equally. But not all of it gets scattered the same. Here, maybe 50% of the light always gets scattered. In Rayleigh, as seen here, right, at different colors, they get scattered differently. So, when we look up into the sky, the reason why we see the color blue the most is because all the blue color is getting scattered around. So you can actually see it. So it's all over the sky. And the reason the sun is white is that MIE scattering scatters most of it directly towards you, right? So you see a mix of all the colors as all the colors get scattered equally at 50%. So you see the sun as white and you see the sky as blue. And that is a quick explanation of what happens in our sky and why it is the color it is.